Now let us talk about the installations of strain gauge on the surface of concrete and mortar. First, you will need to prepare the surface. Remove any laths, paint and other soiling from gauge installation area on the test specimen in order to provide a clear contact surface. What does it mean by the laths? It is a substance that floats out and is precipitated out onto the surface of concrete or mortar when water is expelled as the concrete and mortar hardens. In another word, this laths appears on the surface of fresh concrete. It is basically due to the fine particles coming out from the fresh concrete as it hardens. It is basically impurities to the surface of concrete, which may ultimately affect the bond conditions between the strain gauge and the concrete. You will need to remove these impurities so that the strain gauge can properly bond to the test specimen, allowing the adhesive to effectively convey the strength as developed in the concrete to the strain gauge. You will need to make sure the surface of the concrete is dry, as adhesive may have problem hardening if the test specimen is wet. Next is about sanding. You will need to evenly sand an area of 20 to 30 mm larger than the strain gauge, where it should be installed, by using abrasive paper. Now, depending on the test specimen material, grade 80 to 120 abrasive paper should be used to finish the surface. Next is cleaning the abraded surface with industrial tissue or cloth damp with a small amount of solvent such as acetone. This process cleans the impurities from the surface of the concrete or mortar. After done preparing the surface, there will be a process of pre-coating. This pre-coating is provided on the surface where you intend to install the strain gauge, and it should be laid before the installations of the strain gauge. The purpose of pre-coating here is to render the surface of the mortar or concrete, make it flat and provide surface for the strain gauge to be readily bond. You know that even though the surface has already been sanded, you will still expect a rough surface on the concrete. This may also influence the quality of the bond between the strain gauge and the test specimen. Now, if the bonding quality is not good enough, whichever strength developed within the test specimen may not be fully conveyed to the strain gauge. This may result in inaccurate measurements of the strain gauge. Now, this pre-coating provides areas for the strain gauge to be properly bond onto the test specimen. As it is laid in between the strain gauge and the test specimen, you will require this pre-coating to be strongly bond with the test specimen, and then the strain gauge to be bonded on the pre-coating. This pre-coating also has another function. It acts as a barrier against the dampness that exudes from the surface of the concrete or mortar. This prevents the absorption of the moisture by the underside of the strain gauge. You know that moisture is something that we do not like when using the strain gauge. It may affect the readings of the strain gauge. Now, this pre-coat can be done by using the PS adhesive, and the successful applications of this pre-coat is the most important factor in the successful measurements of strength in concrete and mortar. Knowing about the importance of pre-coating, let us proceed our discussions on preparing this pre-coating for the installations of the strain gauge. First is about cutting the gauge binder. What is the gauge binder? Normally, every strain gauge comes with its gauge binder. This is the gauge binder. It protects the strain gauge and prevents the direct contact of your fingers to the surface of the strain gauge. It serves as a cover to the strain gauge. Once the strain gauge is taken out from its package, it comes together with the gauge binder. You may take out the strain gauge, and there is a gauge binder here. Cut the gauge binder supplied with the strain gauge about 5 mm in front of the foil. Cut the line here, and you will take out a piece of rectangular gauge binder, and the size is more or less the size of the strain gauge. Next is about the masking. Use gum tape to mask an area roughly 10 mm larger on each side than the cut piece of gauge binder. You need a slightly larger area for the installations of the strain gauge. Now you use this gauge binder as a reference for you to determine the size of the masking. You allow an additional of 10 mm offset distance from the size of the gauge binder. Now remove the gauge binder here and apply the PS adhesive. You will need to follow the procedures as given in the instructions in terms of the applications of PS adhesive. And then brush the adhesive fully into the mortar or concrete, as demonstrated in the figure here. You may need to apply an additional layers of PS adhesive so that a layer of 0.5 mm to 1 mm thick is formed, and this PS adhesive shall act as the contact surface between the strain gauge and the test specimen. After you have laid the coating, use the gauge binder that you prepared just now. Lay it onto the adhesive, something like this. As you lay it, press it onto the place gradually from one end to another. Make sure you remove all the air bubbles underneath the gauge binder that may have trapped under the binder. Press the binder down slightly in order to expel any excessive adhesive and air bubble. This shall produce an indented surface on the coating material, where this surface shall ultimately be the locations where you're going to install the strain gauge. Use this gauge binder to create that surface. Make sure it is flat and without any air bubble. If the surface of this coating material is unflat, this may influence the bonding quality of the strain gauge onto the coating. Once this is done, you may remove the gauge binder. Peel off the gauge binder once the adhesive is hardened. After that, you may install the strain gauge. Please take note that you will need to remove the gauge binder before you install the strain gauge. The strain gauge is not supposed to be installed onto the gauge binder, as you cannot guarantee the bond between the gauge binder and the coating. Now ultimately, you will see the coating lay onto the surface of the test specimen, which is concrete or mortar, and then the strain gauge lay on top of the coating. This is how you install the strain gauge on the mortar and concrete.